Design number 5, as I mentioned, we have to cover today. So that design relates with the hydrograph and more precisely with the derivation of unit hydrograph. So you will also learn in your some of your theory topics hopefully in the coming weeks about the hydrograph, about the unit hydrograph. So over here, I will briefly discuss hydrograph and its components, its parts, and then we'll be more focused on the derivation of unit hydrograph from the given hydrograph of an isolated storm. So let's start with the statement. Following are the ordinates of a storm hydrograph for a river draining catchment area of 400 square kilometer due to a 6-hour isolated storm. Derive the ordinates of 6-hour unit hydrograph for the catchment. So let me come to the data that you are given with at the end of these slides. So this is the data given to you, time to start in hours and the discharge in cubic meter per second. So this is the given data to you for this design, and you have been given that there is a catchment area of 400 square kilometer of a river, and as a result of 6-hour rainfall on that area, it produces certain flow or discharge at the outlet of that area or basin area or catchment area, and that discharge has been recorded or measured with respect to certain time interval. So after every 6 hours the discharge is measured and accordingly the data is given. So this is 6 hourly discharge data is given as a result of 6-hour rainfall over the area. So in the first time step, that is minus 6 hours. So this is not the minus time, it is actually on the negative x-axis. That's why the minus sign is coming. So it shows that when before the rainfall started, there was certain flow or discharge in the channel at the outlet, which was recorded as 10.9 cubic meter per second. At the zero time, when the rainfall just started, still certain discharge was there in the channel at the outlet, which was recorded as 9 cubic meter per second. Now after 6 hours of the rainfall, now the discharge started increasing. It became from 9 cubics to 30 cubics. It means that now the contribution of the rainfall over the area has started reaching the outlet of the catchment or outlet of the drainage basin. Similarly, for the next 6 hours, after next 6 hours mean 12 hours from the zero, its discharge is further increased, and there is further increase in the discharge up to 102.5. This is the maximum or peak discharge recorded at the outlet uh, at 24 after 24 hours from the rainfall. And then further this discharge continued to come down to the outlet, and it accordingly was recorded and up to the 96 hours, and then up to 102 hours, the again discharge in the river became minimum. So this is the data given to you, that is time versus discharge data given for a 400 square kilometer catchment area where 6-hour rainfall took place and resulted in this discharge recorded with respect to different time steps, 6-hour time step. So this is the given data I've shown to you. So now again let we discuss the
Sir,
statement.
I I
Yes,
have a question.
yes.
सर हमें तो नहीं पता कि एग्जैक्टली रेनफॉल स्टार्ट कब होगी, तो उससे हम बिल्कुल एग्जैक्टली 6 आवर्स बिफोर कैसे डिस्चार्ज नोट कर सकते हैं?
जी जी
-6.
जी ये if you look at this hydrograph, this is the discharge versus time relationship. On y-axis we have discharge, on x-axis we have the time. Okay. Now, normally the rainfall starts at time zero. Okay, this is the normal trend we take, that when the time is zero at the x-axis, it means it is the start of the rainfall, and up to 6 hours, this is rainfall continued. So this is called as the rain hydrograph, showing the rainfall intensity with respect to time. So over here we are assuming same intensity rainfalls for 6 hours for this case. So although rainfall, so is it clear that so when the rainfall started, normally we take it as a zero time, okay, just at the start of rainfall. Is it clear?
सर मैं ये पूछना चाह रही थी कि हमने रेनफॉल से पहले जो एक डिस्चार्ज की रीडिंग ली थी वो हमने एग्जैक्टली 6 आवर्स बिफोर कैसे ली? मतलब हमें क्या पता कि 6 आवर बाद रेन स्टार्ट हो जाएगी और फिर हमने जीरो से
जी जी,
स्टार्ट किया।
that is the routine measurement. Normally, when you talk about the river, so normally we keep on measuring certain stage and discharge values on routine basis, and that is just for the data given to you. Otherwise, that time may be different. Maybe 3 hours before rainfall the reading is taken, or 10 hours before rainfall the reading is taken. So that is just the given data. Okay. Otherwise, the time is not exactly 6 hours all the time or every time. Okay.
ओके सर।
तो हमने एक रूटीन रीडिंग ली, डिस्चार्ज मेजर किया, और उसके बाद रेनफॉल आ गई। और जब रेनफॉल शुरू हुई और तब से लेके जब रेनफॉल एंड हुई, वो 6 आवर की ड्यूरेशन है रेनफॉल की, जो कि उस एरिया में हुई। और उस 6 आवर रेनफॉल की वजह से क्या हुआ कि डिस्चार्ज बढ़ना शुरू हो गया आउटलेट पे, बढ़ता बढ़ता पीक पे आया, फिर दोबारा कम होना शुरू हो गया, फिर दोबारा मिनिमम पे आ गया। सो दिस इज अ टिपिकल रेनफॉल result hydrograph resulting from an isolated storm. This is called as isolated storm, कि एक अलहदा से 6 घंटे की बारिश हुई, और उस बारिश की वजह से जो है आउटलेट पे पानी आया ड्रेनेज एरिया से होता हुआ रिवर के आउटलेट पे या ड्रेनेज एरिया के आउटलेट पे। उसको हमने मेजर किया डिफरेंट टाइम स्टेप्स पे। तो यहाँ टाइम स्टेप 6 आवर है कि हर 6 आवर के बाद हमने रीडिंग ली है, और हमने देखा कि पहले डिस्चार्ज बढ़ता जा रहा है, रेनफॉल की कंट्रीब्यूशन आती जा रही है, एक पीक के वैल्यू आ जाती है, उसके बाद फिर जो बाकी वाटर रह जाता है एरिया में वो आना शुरू होता है। दिस इज कॉल्ड रिसीडिंग, कि वाटर स्टार्ट रिसीडिंग फ्रॉम द वाटरशेड, और उसके बाद दोबारा फिर मिनिमम डिस्चार्ज उसमें आ जाता है। तो वो जहाँ दोबारा से मिनिमम आता है तो वहाँ तक वो बेसिकली रेनफॉल की कंट्रीब्यूशन है, जिसकी वजह से डिस्चार्ज बढ़ा था, या कुछ बेस फ्लो कंट्रीब्यूशन है। ठीक है, अभी क्लियर है?
ओके सर।
So following are the ordinates. Ordinate mean discharge value of a storm hydrograph. Storm hydrograph mean hydrograph resulting from an isolated rainstorm. For a river draining catchment area of 400 square kilometer, तो ये 400 स्क्वायर किलोमीटर कैचमेंट एरिया जिस पे बारिश हुई, आइसोलेटेड एक रेन स्टॉर्म आया, जिसकी वजह से एक हाइड्रोग्राफ जनरेट हुआ, दैट इज स्टॉर्म हाइड्रोग्राफ। Due to 6 hour isolated storm or rainfall event, derive the ordinates of 6 hour unit hydrograph for the catchment. So over here, I will mention that duration of the hydrograph. So for every hydrograph, remember this duration is mentioned. So the storm hydrograph for which the data is given to you, time versus discharge data, it is a 6 hour unit hydrograph. So normally the duration of a hydrograph is the duration of the rainstorm as a result of which that is obtained. So we have a 6 hour hydrograph resulting from 6 hour isolated storm or rainfall, and the duration of the unit hydrograph will be the same as the storm hydrograph. तो जो हाइड्रोग्राफ किसी खास बारिश या किसी खास ड्यूरेशन की रेनफॉल से आता है, वही ड्यूरेशन उस हाइड्रोग्राफ की होती है, दैट इज द ड्यूरेशन ऑफ द हाइड्रोग्राफ as a result of which that is obtained or generated. And whatever unit hydrograph we derive from the given hydrograph, same will be the duration of that hydrograph, that unit hydrograph. तो हाइड्रोग्राफ की ड्यूरेशन जो है किसी भी, वो उस रेन स्टॉर्म की ड्यूरेशन होती है जिसकी रिजल्ट में वो हाइड्रोग्राफ जनरेट किसी भी आउटलेट पे ऑफ कैचमेंट के। और कोई भी अगर हम यूनिट हाइड्रोग्राफ डिराइव करेंगे किसी भी हाइड्रोग्राफ से, तो उस यूनिट हाइड्रोग्राफ की ड्यूरेशन वही होगी जिस हाइड्रोग्राफ से उसको डिराइव किया गया। सो दिस ड्यूरेशन इज वेरी वेरी इंपॉर्टेंट टू मेंशन, and it shows that this hydrograph is a result of that much duration rainfall or effective rainfall. So you are given with the time versus discharge data. If you plot it on y-axis keeping discharge, selecting a suitable scale, and on x-axis keeping time, so you end up having the hydrograph. This is the hydrograph, typical hydrograph, discharge versus time relationship. So this is actually given to you, that is the given data. Now what you have to do, you have to derive the unit hydrograph, 6 hour unit hydrograph for the catchment from the storm hydrograph given to you. So that procedure I will discuss later on. First of all, you should know what is a hydrograph. It is a graphical representation of flow against time for a particular section of the stream or river, as I mentioned. So on variable kept on y-axis is flow or discharge, and on x-axis we have the time as the variable. So if you plot this graph, you end up having a graphical representation of flow against time, which tells you that at every time step at which discharge is measured, what is the ordinate, what is the discharge of the hydrograph. So this graphical information is given by this hydrograph. Parts of hydrograph. Hydrograph consists of essentially four parts. Groundwater recession curve. This is the right at the start. Rise and sometime if you have some intermittent rivers which run only during the rainfall, so you may not have this recession curve. This is for those rivers for which we have the groundwater contribution. So ऐसे rivers जहाँ पे ग्राउंड वाटर का फ्लो भी रिवर तक पहुंचता है, वहाँ ये ग्राउंड वाटर रिसेशन कर्व का पार्ट आता है. अदरवाइज अगर ऐसा रिवर है जो कि जब बारिश होगी तभी उसमें पानी आता है, तो उसका स्टार्ट जो पहला होगा वो राइजिंग लिम से ही होगा. देन द पीक, राइजिंग लिम सेकंड पार्ट, पीक, एंड देन द रिसेशन कर्व एंड द लिम फॉलिंग लिम, और देन अगेन वी हैव द ग्राउंड वाटर रिसेशन कर्व ऑन द डाउनस्ट्रीम. Now this shows the typical components of the hydrograph. If you see, this part is the groundwater recession curve. This shows that before the rainfall contribution came at the outlet, some water was already there in the river, that was from the base flow or from the groundwater. This is called groundwater recession curve. So it is receding, actually it is having recession. ये कम हो रहा है इसलिए इसको रिसेशन कर्व बोलते हैं. क्योंकि ये ग्राउंड वाटर की कंट्रीब्यूशन है सिर्फ, तो इसको ग्राउंड वाटर रिसेशन कर्व बोलते हैं. When once the rainfall started, and its contribution started at the outlet. रेनफॉल हुई, उस रेनफॉल की वजह से रन ऑफ जनरेट हुआ, और वो रन ऑफ जब आउटलेट तक पहुंचा, सो देयर विल बी राइज इन द हाइड्रोग्राफ. तो हाइड्रोग्राफ ऑर्डिनेट विल स्टार्ट टू राइज, डिस्चार्ज बढ़ना शुरू हो जाएगा आउटलेट पे. This part is called rising limb. Right at the start of the point of rise, up to the peak or crest of the hydrograph, this is called rising limb. So rising limb shows that how much is the contribution of the rainfall at the outlet and how quick is that contribution. More quick contribution, like in case of rainfall, than the snow melt. There are many factors which affect the rising limb and the slope of this rising limb. It can be steeper slope, it can be a milder slope. With more peak, in case of steeper slope, less time to peak, more peak discharge, and more quick peak discharge. And secondly, less peak discharge and more time to peak. तो इसमें दो तरह से पॉसिबिलिटीज़ हैं शेप ऑफ हाइड्रोग्राफ से. राइजिंग लिम की स्लोप स्टीप हो सकती है, ज़्यादा पीक डिस्चार्ज हो सकता है, और कम टाइम टू पीक हो सकता है, कम टाइम में ज़्यादा डिस्चार्ज आएगा. दूसरा, इसमें ज़्यादा कम पीक डिस्चार्ज हो सकता है और ज़्यादा टाइम टू पीक हो सकता है. सो राइजिंग लिम की स्लोप स्टीप हो सकती है, माइल्ड. So it depends on many factors. It depends on the rainfall characteristics, which are called climate factors, in which intensity of rainfall is involved, in which amount of rainfall is involved, duration of rainfall is involved, in which we have the rainfall distribution near the outlet, away from the outlet, movement of the rainfall towards the outlet or away from the outlet. So many factors relating to the rainfall characteristics are involved. So all those factors, like more intensity, more amount, more type of rainfall, like type of the precipitation, like rainfall. So all those factors, we tend to increase the runoff, surface runoff, and they will make this rising limb more steeper, more peak discharge, and less time to peak. Similarly, catchment characteristics, shape of the catchment, land use, land cover of the catchment, slope of the catchment, imperviousness of the catchment, type of the soil of the catchment, etc. So they will also affect this slope of the rising limb. All the factors relating to catchment characteristics, which will tend to increase the runoff, which will produce more quick runoff over the watershed, they will make the rising limb more steeper, more peak discharge, and less time to peak. So this is the rising limb of the hydrograph affected by the rainfall characteristics as well as by the catchment characteristic. More peak discharge, less time to keep peak, more slope of the rising limb, and vice versa. Third component is the crest or peak discharge. Again, it is affected by the rainfall characteristic and the catchment characteristic. more quick peak discharge, more will be the value of the peak discharge or crest, and less will be the time to reach this crest. Then we have the falling limb or recession limb. So once the peak is achieved, ordinates of the hydrograph, discharge of the hydrograph at different time sets start reducing. So this shows that now the water has started receding from the watershed at the outlet. Maximum water has passed from the outlet, and now the remaining water is coming to the outlet from the catchment, and this shows the receding or recession of the hydrograph. Now remember this recession starts normally when the rainfall is stopped. जैसी रेनफॉल ख़त्म होती है तो उसके कुछ देर बाद जो है रिसेशन शुरू हो जाती है, ये फ्लो जो है कम होना शुरू हो जाता है. So normally this peak is up to the time of concentration. So if the rainfall duration is equal to the time of concentration or more than that, so we normally achieve the true peak, true response of the watershed, full response of the watershed. But if the duration of rainfall is less than the time of concentration, so we may achieve the earlier peak and full response of the watershed is not achieved. So that's why whatever rainstorm we select for the hydrograph and then for the unit hydrograph must have the duration at least equal to time of concentration, which is the time after which water from all parts of the watershed will reach the outlet, mean full response of the watershed will be achieved. So if the time duration of the rainfall is more than time of concentration, so that this peak will be flattened. तो ये पीक जो है ज़्यादा देर तक रहेगी आउटलेट पे, ज़्यादा देर तक पीक डिस्चार्ज चलता रहेगा, और बेटर आइडिया यही है कि ड्यूरेशन जो है वो एटलीस्ट टाइम ऑफ कंसंट्रेशन के बराबर होनी चाहिए. नाउ फॉलिंग लिम्ब एज आई मेंशन स्टार्ट्स व्हेन द रेनफॉल नॉर्मली स्टॉप्स. जब रेनफॉल ख़त्म होती है तो फॉलिंग लिम्ब शुरू हो जाता है, डिस्चार्ज कम होना शुरू हो जाता है. सो दिस फॉलिंग लिम्ब डज नॉट डिपेंड ऑन द रेनफॉल कैरेक्टरिस्टिक, it only depends on the catchment characteristic. So all the factors we tend to decrease the runoff, less slope, more elongated shape, etc. So they will tend to make this falling limb more or less steeper accordingly. So this is affected by the catchment characteristic falling limb. Then again we have, after this effect of the rainfall, that is direct runoff is ceased or finished, then we again have the base flow running in river, and we achieve the rainfall base flow recession curve also. So these are the parts of hydrograph: groundwater recession curve, rising limb, peak and recession limb. So these are result of the rainfall contribution, and then again we have the downstream groundwater recession curve. Next are the components of hydrograph. Hydrograph has two main components: direct runoff (DRO), which is also called the surface runoff, and the base flow or the groundwater flow. So you can also see these components. So hydrograph can be divided into two parts: direct runoff, and it can be divided into the other part, that is base flow. So this all from this recession limb, recession curve to this horizontal line or inclined line approximately, and this recession curve, this all is the base flow, and above part is the direct runoff. So rising limb, falling limb, crest are a result of the direct runoff. Otherwise, the base flow remains fairly consistent in the channel, and its contribution is quite less as compared to DRO, quick runoff, and also its recession is at a constant rate or at an exponential rate sometime. So components of hydrograph are direct runoff and base. Factors affecting the shape of hydrograph. As I mentioned, shape of hydrograph is mainly influenced by the rising limb, crest and the falling limb. So either it can be a steeper hydrograph or it can be a milder hydrograph with more time to peak, less peak, more rising slope, more milder rising slope, more milder falling limb. So different possibilities of the shape are there. So all this affected by two main factors, as I mentioned. Shape of hydrograph, main factors affecting the shape of hydrograph are basically two: the climate factor, and secondly are the physiographical factors. Climate factors include the amount of rainfall, intensity, duration, while physical characteristics of watershed include the shape of basin, slope of watershed, surface condition of catchment, soil type, etc. So these are one way or the other affect the shape of hydrograph, either to have the steeper slopes of the rising and falling limb, or the milder slope, more peak, less time to peak, or less peak with more time to peak. Hydrograph separation. Hydrograph separation means splitting the hydrograph into ordinates of base flow and direct runoff. अगर आप टोटल जो हाइड्रोग्राफ है उसके ऑर्डिनेट्स को दो हिस्सों में डिवाइड कर दें, बेस फ्लो में और डायरेक्ट रन ऑफ में, दैट इज कॉल्ड हाइड्रोग्राफ सेपरेशन. So there are different methods available for the separation of hydrograph. Over here we will discuss few methods, important one. One is the straight line method. Under that we have further two methods, horizontal straight line method and inclined line method. Horizontal straight line method is also called as the constant discharge method, in which we assume that the base flow remains constant throughout the time base of the hydrograph. Inclined line method, also called as the constant slope method, in which we assume that the base flow uh, changes at a constant, following a constant rate r. Then we have the fixed base length method, in which it is mentioned that firstly the base flow is reduced up to the peak, and then after the peak the base flow start increasing, and then again we have the recession at the end, and then the variable slope method. So these are the methods that are used to separate the direct runoff ordinates from the base flow of the hydrograph, which is called hydrograph separation or separation of hydrograph base. So all these methods are explained over here. First of all, in horizontal straight line method, a horizontal line is drawn from the point of rise. The area below the line is the base flow, and the line is based on the assumption that constant amount of base flow is maintained during the storm runoff. It produces an extremely long time base of the DRO. What is time base of a hydrograph? Time base of a hydrograph means that the time elapsed between the end of the hydrograph and the start of hydrograph. तो स्टार्ट ऑफ हाइड्रोग्राफ से एंड ऑफ हाइड्रोग्राफ तक जितना भी टाइम है, दैट इज द टाइम बेस ऑफ हाइड्रोग्राफ. व्हाट इज टाइम बेस ऑफ DRO? So DRO hydrograph starts at the point of rise and ends at the point of inflection, when the recession again starts, when the curvature of the falling limb changes. So that is the point of inflection. Normally this point is located from the peak with a formula. So this is what we do. We start from the point of rise, we locate the point of rise, and we draw a horizontal line to meet the other end of the hydrograph. So all this below this point, this line and this recession curve, all this is the base flow, and above it is the direct runoff. So this is a separation of hydrograph into direct runoff ordinates and the base flow ordinates by the simplest of the method, assuming that the base flow remains constant, and this produces the longest time base for the DRO. Second method is the inclined line method. In inclined line method, it is obtained by joining two points, that is where the DRO enters, that is the start of the rise of hydrograph, and where the DRO ceases, that is the point of inflection. DRO ceases after n days from the peak discharge and is obtained by the following relationship. So you find this n, which is equal to k, which is 1 for the area in square miles and 0.8 for the area in square kilometers. So you are given with the area in square kilometer, so you will use this k as 0.8. A is the watershed area, you are given as 400 square kilometers, so you will use that as it. So area should be in square kilometer, should be put into that. So you will find n in this way. You will find this n in days because the data is given in hours. So you will find the time in hours. Whatever hours you will get, so you will move that much hours from the peak up towards this downstream end, and you will mark a point over there. So this point, which is the point where the DRO ceases or finishes, it is n hours away from the peak. तो आप n फाइंड कर लेंगे, जितने आवर आएंगे पीक से लेके वहां तक आप एक पॉइंट लगा लेंगे n आवर्स का पीक से. सो वो पॉइंट आ जाएगा आपके पास रिसेशन साइड पे, या इन्फ्लेक्शन पॉइंट आ जाएगा. सो व्हाट यू डू इन इंक्लाइन लाइन मेथड, you select the point of rise where the DRO starts, and you find the point which is n days or n hours away from the peak, and you join both the points by an inclined line, which is called the inclined line method, as the constant slope method. Now these two methods are explained over here. Firstly is the horizontal line method. You select the point of rise on the hydrograph, and you draw from there the horizontal line joining the other end of the hydrograph. So this all is the base flow. You find the ordinates of the base flow at different time steps, and you subtract from the ordinates of hydrograph. Remaining are the ordinates of the DRO that you can find. Second method is the inclined line method or constant slope method. In this method, this point of rise is same that you select, and you select another point that is n days away from the peak. By the formula, you mark that point and you join both by the inclined line. So that is called inclined line method. So you have to use this method for your this design 5. तो आपने इस मेथड को यूज़ करते हुए बेस फ्लो को सेपरेट करना है और DRO को सेपरेट करना है यूजिंग द इंक्लाइन लाइन मेथड. तो आप जब हाइड्रोग्राफ बना लेंगे, डाटा प्लॉट कर लेंगे, यू हैव टू सिलेक्ट कहाँ से हाइड्रोग्राफ बढ़ना शुरू हुआ है, दैट इज़ द पॉइंट ऑफ राइज, और फिर आप एक पॉइंट और निकाल लेंगे एन डेज फ्रॉम द पीक और इन दोनों को इंक्लाइन लाइन से मिला देंगे. सो दैट विल बी द, सो इन दिस केस दिस ऑल इज़ द बेस फ्लो. तो इस पे जम्पशन यही है कि बेस फ्लो जो है वो कांस्टेंट स्लोप के साथ बढ़ रहा है, कांस्टेंट रेट के साथ बढ़ रहा है अप टू दिस पॉइंट और फिर दोबारा कम होना शुरू हो जाता है. सो दिस ऑल इज़ द बेस फ्लो इन दिस केस एंड रिमेनिंग इज़ द DRO. The third method is explained in fixed base length method. A line AB is drawn in the extension of groundwater recession curve ending at peak of hydrograph. Another line BC is drawn from the point B to C where DRO ceases at the distance n days from the peak of hydrograph. The area of the hydrograph above the curve ABC is DRO and below the is base flow. Now let me explain the third method. This is second method. Third method is, first of all, you draw a line AB in extension of this recession curve. This is the recession curve. You draw a tangent to this recession curve and you extend the line up to the peak. You draw another line, vertical line from the peak, which will join the extension of recession curve. So this blue line and the red line will join at under the peak. Now, with the point where these two join, you will draw another line from that point up to the point which is n days or n hours from the peak, just like the second method. जिससे आप second method में वो point निकाल लेंगे n निकाल के, इसी तरह उस point को वही रखेंगे और एक लाइन लगा देंगे जहाँ पे recession curve की extension और peak का लाइन मिल रही है, वहाँ से इस point तक लाइन लग जाएगी. So this is, now in this case this all is the base flow. So in this method it is assumed that firstly base flow is reduced, it keeps on reducing up to the peak and then start increasing up to this point and then start reducing again, and remaining this all is the DRO hydrograph in this case. This is the third method over here, that is the fixed base length method. Fourth is the variable slope method. That is not a common method. In that method, the first it is similar to the fixed base length method that you draw a line in extension of the recession curve. They draw a line to the peak, they meet together. Then you draw another line. Over here, this is the difference. Then you draw again another tangent to the downstream recession curve, and you mark a point parallel to this point n days from the peak, and you join this point with that point. So slight variation in this slope is there depending on the downstream recession curve. That is the variable slope method. So in this way, you can separate the base flow from the DRO. That is called separation of hydrograph. So that is the part of your design. You have to do it by the second method, inclined line method. Coming to the unit hydrograph. Now unit hydrograph is the direct run of hydrograph with unit effective precipitation over the entire watershed, that is 1 centimeter or 1 inch. अगर किसी watershed पे 1 इंच और 1 सेंटीमीटर effective बारिश हो, effective rainfall हो, what is effective rainfall? That is total rainfall minus losses due to evaporation, infiltration and transpiration. तो बाकी जो rainfall बचेगी that is effective rainfall. तो अगर किसी एरिया में 1 सेंटीमीटर या 1 इंच effective rainfall हो, तो उसके रिजल्ट में जो हाइड्रोग्राफ बनेगा that is called as unit hydrograph. It is a hypothetical hydrograph actually that we make by ourselves taking some assumptions, and this is derived from the direct run of hydrograph. तो इसमें स्टेप्स यही होते हैं कि सबसे पहले आपको जो डाटा दिया हुआ यू प्लॉट इट, एंड व्हेन यू प्लॉट दैट डाटा यू गेट द isolated hydrograph. From that hydrograph, so for that hydrograph you derive uh, the direct run of hydrograph after separating the base flow, and then from that direct run of hydrograph you derive the unit hydrograph. So this is the procedure that you follow to derive the unit hydrograph. So that is also mentioned. Application of unit hydrograph. So unit hydrograph is used to find the design or the peak discharge for any effective precipitation other than the unit precipitation. So unit hydrograph is used for the prediction of flood peak and the time to peak in a stream at a particular section due to any amount of effective precipitation over the watershed. तो जब आप किसी जगह का यूनिट हाइड्रोग्राफ बना लेते हैं तो आप किसी भी प्रेसिपिटेशन की बेस पे जो कि सेम ड्यूरेशन की जिस ड्यूरेशन का यूनिट हाइड्रोग्राफ है, ये से इसमें कंडीशन है कि द अमाउंट ऑफ प्रेसिपिटेशन फॉर विच पीक डिस्चार्ज एंड टाइम टू पीक इज टू बी डिटर्मिन्ड और द हाइड्रोग्राफ इज टू बी मेड शुड बी ऑफ सेम ड्यूरेशन एज ऑफ द यूनिट हाइड्रोग्राफ. तो उस ड्यूरेशन की कितनी जो भी इफेक्टिव प्रेसिपिटेशन होगी उसकी बेस पे आप डिज़ाइन डिस्चार्ज या हाइड्रोग्राफ बना सकते हैं यूजिंग द यूनिट हाइड्रोग्राफ. So this is one major use of the unit hydrograph. It is used to find the design discharge and is used to generate the hydrograph of any effective precipitation other than the unit effective precipitation. There are some assumptions under which unit hydrograph works. Number one, amount of precipitation over the entire area must be same. Precipitation intensity must be same throughout the area. Now, keeping view these two factors are assumptions, it is applicable to smaller areas and especially to those watersheds which are fed mainly by the rainfall. तो इन छोटे एरियाज़ के लिए ज़्यादा बेटर रिजल्ट देता है. बड़े एरियाज़ में चूँकि अमाउंट ऑफ रेनफॉल या इंटेंसिटी ऑफ रेनफॉल कांस्टेंट नहीं होती पूरे एरिया के लिए, तो वहाँ इतने बेहतर रिजल्ट नहीं आते. बेस लेंथ ऑफ हाइड्रोग्राफ DRO या DRO हाइड्रोग्राफ फॉर अ पर्टिकुलर कैचमेंट रिजल्टिंग फ्रॉम अ स्टॉर्म ऑफ अ गिवन ड्यूरेशन इज अप्रॉक्सीमेटली कांस्टेंट. तो जो टाइम बेस है डायरेक्ट रन ऑफ हाइड्रोग्राफ की, वो किसी भी ड्यूरेशन का स्टॉर्म हो उसके लिए सेम रहनी चाहिए. भी एक एजम्पशन है इसमें. एंटायर वाटरशेड इज ट्रीटेड एज अ सिंगल यूनिट. सो पूरे वाटरशेड में जो स्लोप है, जो उसकी सॉइल टाइप है, लैंड यूज वगैरह है, वो सेम होना चाहिए. इट शुड बी ट्रीटेड एज अ सिंगल यूनिट. So these are some assumptions under which unit hydrograph is worked or it is considered. Now coming to the procedure to derive the unit hydrograph. First of all, you will plot the given data, you will achieve the hydrograph. You are given in the manual two separate graph sheets. On one graph you have to make the separate hydrograph, isolated hydrograph. Yes, just you have to plot the data of discharge and time, selecting a suitable scale. And on the same graph you have to separate the base flow and the DRO. The second graph sheet is given to you where you will plot the DRO hydrograph and the unit hydrograph on that graph. So इस तरह आपने इनको बनाना है. So you have to plot the unit hydrograph or the given data. Then you have to separate the base flow using the inclined line method and the DRO. तो आप inclined line method से base flow के ordinates को निकाल लेंगे, लैदा कर लेंगे, और जो ऑर्डिनेट्स हाइड्रोग्राफ के हैं माइनस ऑर्डिनेट्स ऑफ बेस फ्लो, बाकी आपके पास DRO के हाइड्रोग्राफ ऑर्डिनेट्स आ जाएंगे. आफ्टर दैट यू हैव टू फाइंड द वॉल्यूम ऑफ DRO इन क्यूबिक किलोमीटर और क्यूबिक फिट. तो आपको चूँकि क्यूबिक किलोमीटर में स्क्वायर मीटर में दिया हुआ है, स्क्वायर किलोमीटर में एरिया दिया हुआ है, तो यू विल फाइंड द वॉल्यूम इन क्यूबिक किलोमीटर. हाउ टू फाइंड द वॉल्यूम ऑफ DRO? You will sum the ordinates of all ordinates of DRO, multiply with time step. Over here time step is 6 hours and you will convert hours into seconds. So 1 hour has 60 into 60, 3600 seconds. So by this formula or by finding the area under the DRO hydrograph, you can find the volume of DRO hydrograph. Next step is you will divide the volume of the DRO hydrograph in the third step with the area of watershed, that is 400 square kilometer. So you will get the X value in kilometer, then you can convert into meters and then centimeters. So you have to find the value of X, which is volume of DRO divided by area of watershed. So X is volume, this is called effective precipitation, volume of DRO divided by area of watershed in centimeter that you have to find. After that, you have to compute the ordinates of unit hydrograph. So ordinates of unit hydrograph are ordinates of DRO divided by this x calculated in the fourth step. तो जो DRO के ऑर्डिनेट्स है उसको आप x से डिवाइड कर देंगे, तो इस तरह आपके पास यूनिट हाइड्रोग्राफ के ऑर्डिनेट्स आ जाएंगे. You will plot again ordinates of unit hydrograph with time, so you will get the unit hydrograph. After plotting the unit hydrograph, you have to plot the DRO hydrograph and unit hydrograph on the same graph. After plotting the unit hydrograph, you have to check whether the area under unit hydrograph is 1 centimeter or not. So for this, you will count, either you can count the number of squares under the unit hydrograph plot, mean find the area and divide by the watershed area. So answer should be 1 centimeter or 1. Or you can again find by this way the volume of the unit hydrograph, that is summation of all the ordinates of unit hydrograph into delta T into 3600 divided by the catchment area. So that should be 1 centimeter. तो फॉर्मूले से भी कर सकते हैं या उस हाइड्रोग्राफ के अंडर जो एरिया निकाल के भी आप कर सकते हैं. सो दिस इज हाउ you have to fill this table. You are given with the time and the discharge. You will plot it to get the hydrograph. Then using inclined line method, you will separate the base flow. You will find the ordinates of the base flow against each time step. And then you will find DRO. DRO is column 2 minus column 3. So you will subtract the base flow ordinates from the discharge, total discharge, and you will find the DRO. You will sum the DRO ordinates, multiply by delta T, that is 6 hour, multiplied by 3600, that will be volume of DRO, divided by the area of watershed, that you will get X. Then DRO column 4 divided by X will give the ordinates of unit hydrograph. So you will plot column number 5 with time, column number 4 with time on one graph. So you will get the DRO hydrograph, and under that you will get the unit hydrograph. You have to again find sum the ordinates unit hydrograph, multiply with delta T 6 hour, multiply by 3600, that will be volume of the unit hydrograph divided by the area of watershed. So that should be again 1 centimeter. That is the check for it. Then you will comment on the results. What is the peak of unit hydrograph you have obtained? What is the x value you have obtained? Effective precipitation. What are the what is the check for the unit hydrograph? Is it okay or not? So these things you have to write the result, and then you have to accordingly comment on the results. So this is about today's design. Now I will move to the questions from your side. If anybody having, so can ask or she can ask, so that you can understand and you can do it at your places. Yes, any questions from your side from today's job? तो काफ़ी कम स्टूडेंट्स ने अटेंड किया आज का भी. आपकी जो सेक्शन ए की स्पेशली अटेंडेंस जो है लैब में काफ़ी कम होती है बाकी सेक्शंस की निस्बत. एनी हाउ, any question from your side before I mark the attendance?
Yes sir. सर काइंडली ये बता दें कि 4 डिफरेंट मेथड्स किन 4 केसेस के लिए है.
इसमें केसेस नहीं है. इन मेथड्स को कोई भी मेथड यूज़ किया जा सकता है. इसमें हर मेथड की अपनी जो है वो एक एग्जम्पशंस हैं. जैसे पहला मेथड है उसमें वो कहता है जी बेस फ्लो कांस्टेंट रहता है, जो कि इतना ट्रू नहीं है. सेकंड मेथड उसमें कहता है बेस फ्लो जो है वो कांस्टेंट रेट से बढ़ता है, जो कि कुछ बेहतर आइडिया है. थर्ड मेथड कह लेंगे ज़्यादा, उसमें नियर टू फील्ड कंडीशन या एक्चुअल कंडीशन है. तो इस तरह ये इनकी एक्यूरेसी की है. अदरवाइज इनमें से कोई भी मेथड यूज़ किया जा सकता है.
तो सर इन रियल हम किस मेथड पे ज़्यादा रिलाय करते हैं, क्योंकि सबके बेस फ्लो की वैल्यू तो वेरी करेगी.
जी जी, जैसे जो थर्ड मेथड है ना, जो फिक्स बेस लेंथ मेथड है, उसमें ज़्यादा रियलिटी है कि सबसे पहले बेस फ्लो कम होता जाता है और उसके बाद फिर जो है वो बढ़ना शुरू होता है. ठीक है.
ओके सर, थैंक यू.
वेलकम. जी जी, एनी अदर क्वेश्चन फ्रॉम योर साइड relating to today's job?
Sir, in the last step of the procedure where we have to check the area under the unit hydrograph,
Yes.
You told that we can either calculate by formula or by counting the blocks. Can you
Yes.
explain it again, please?
Ji. Okay. So by formula, it just like you did for the DRO, that you sum the ordinates of unit hydrograph multiplied by time step delta t, which is 6 hour, multiplied by 3600, divide by the area. So that is one way to find it out. Or you have you will, when you will plot the hydrograph, like say this is the hydrograph you have plotted, say this is the unit hydrograph. वो इस तरह का नहीं होगा, यूनिट हाइड्रोग्राफ जो है वो इधर यहाँ से और इसका वाई से नहीं शुरू होगा, क्योंकि उसमें बेस फ्लो नहीं होता, तो वो ज़ीरो से इधर से कहीं शुरू होगा और यहाँ पे दोबारा आके मिल जाएगा। एनी तो उसके अंडर जो भी अकॉर्डिंग टू स्केल आप उसका, जैसे आप एरिया अंडर द कर्व निकालते हैं वो निकाल लें और उसको एरिया वाटर शेड से डिवाइड कर दें, सो दैट शुड बी वन आर यूनिटी। ठीक है, अभी क्लियर है
Okay, sir. Thank you.
जी? एनी अदर क्वेश्चन, क्यूरी फ्रॉम योर साइड? So I will advise that still in this lab you have the time remaining, so you should utilize this time in completing this design, so that will also be beneficial for you, that you will can complete at the earliest, and also now you will have the fresh knowledge and you can utilize it to do this job. तो अभी बाकी जो टाइम इस लैब में बचा है उसमें आप बैठ के आपके पास मैनुअल्स भी हैं, या मैंने जो शेयर किया हुआ है सॉफ्ट में वो भी है, उसको देखते हुए आप डाटा अपना लिखें वहाँ पे और मैनुअली, और उसकी हाइड्रोग्राफ को प्लॉट करें और बाद में अगले स्टेप्स करें। सो आई विल रिमेन अवेलेबल इफ़ यू हैव एनी डिफ़िकल्टी थ्रू व्हाट्सएप, यू कैन आस्क द क्वेश्चंस थ्रू द CR और डायरेक्टली। तो इट्स बेटर कि आप इस टाइम को यूटिलाइज करें और इसमें कंप्लीट करें इसको। So now you know that we have the 2 weeks break, holidays, and afterward the classes will resume. So during that time period, you should complete this task, and just when the classes will resume again, we'll discuss design number 6 and 7, and after that you will have to submit all these designs, and you have one evaluation again, and maybe later quizzes when you come on campus. So that's why you should try to complete it at the earliest, so that later on you have other tasks to do and that can be done accordingly. Yes, any questions from your side before I start with the attendance? Okay, let me start with the attendance of your section. 2015 Civil 41, 2018 Civil 1,
Yes, sir.
okay, 2018 CD Civil 1, absent, 2018 Civil 2,
Present, sir.
2018 CD Civil 2,
Yes, sir.
okay, then 2018 Civil 3,
Present, sir.
4,
Yes, sir.
5,
Yes, sir.
6,
Present, sir.
7,
Present, sir.
8,
Present, sir.
11,
Present, sir.
12, 12, 13, 13, 14,
Present, sir.
okay, 15, 15, 16, 1, 6, 17, 18, 19, 21, 21, 22,
Present, sir.
23, 23, 24, 25, 26, 27, 29, 30,
Yes, sir.
30. Okay. 31, 31, 33, 34.
Present, sir.
Okay. 35, 35, 36, 37, 38,
38 present, sir.
42.
Present, sir.
Okay. 43, 43.
सर रोल नंबर 19।
अभी वेट करें यार, अभी आगे करके फिर दोबारा मैं पूछूंगा। 43 इज एब्सेंट। 44,
सर प्रेजेंट।
44. Okay. 45,
93
45, 48, 48, 49.
48%.
ठीक है। 49,
Present, sir.
49.
49. Present, sir.
Okay. 50, 50, 50 roll number.
Yes. Yes, sir. 50%.
Okay. 2018 R 15 civil 105. Yes, 2015 civil 105. नहीं है। 290, 2018 civil 290. Absent. 292.
Yes, sir.
Okay. 2019 R 18 civil 46. Yes, 19 R 18 civil 46. Absent. Yes, anybody else who is left?
सर 19 रोल नंबर।
Okay, 19. Yes, anybody else? So let me repeat who are absent today: 12, 13, 15, 16, 17, 18, 21, 23, 24, 25, 26, 27, 29, 31, 35, 36, 37, 43, 45, 105, 15 civil 105, 290 and 18 civil 46. So these are the absentees today. If somebody is present, so he can tell me. Okay, now anybody having any question from today's job or previous job, here may she ask so that I can answer accordingly. If no question, then I will end this meeting over here and we'll meet again to complete or discuss design number 6 after the holidays. So yes, any question from your side, anybody having? So I will end the meeting over here. You have the slides available.